Yeah, we've heard of gators showing up at the front door. We've seen them in people's swimming pool, but this one absolutely takes the cake. That gator broke in through a low window right there behind me, where you see that board, making this the most Florida story of the week.
For 20 years, pythons have been a nightmare. But what they found lurking beneath the surface makes the pythons look harmless. An invisible enemy is now spreading faster than anyone can stop, and it could change everything. But then, something impossible happened. A creature everyone thought was gone forever just returned. And what it did next left experts speechless. The Florida Everglades has always been one of North America's most remarkable natural landscapes. Spanning over 1.5 million acres across southern Florida,
Their condos and the law. He came 5 condos in, and guess what? The first 4, nobody's living in them. But he got my red wine, the good stuff.
Are you mad about the wine?
Yes.
This vast wetland system is far more than just a swamp. It functions as a slow-moving river of grass, a subtropical wilderness that has sustained an incredibly diverse array of wildlife for thousands of years. The economic value of this ecosystem has been estimated at over $31 billion annually, providing essential services, including flood protection and clean drinking water for millions of residents throughout South Florida. Before the crisis, that would later unfold. The Everglades pulsed with life in every direction. Massive flocks of wading birds, including herons, egrets, and ibises, would fill the sky in numbers so dense they resembled moving clouds. Along the ground, raccoons, opossums, and marsh rabbits moved through the sawgrass, while bobcats and native foxes hunted along the edges of tree islands, known locally as hammocks. This was a functioning, balanced ecosystem where every species played its role in maintaining the delicate equilibrium that had existed for millennia. The catastrophe that would eventually devastate this wilderness began not with dramatic fanfare, but with a series of seemingly unrelated events in the early 1990 seconds. In August 1992, Hurricane Andrew, a catastrophic Category 5 storm, made landfall in southern Florida. With sustained winds exceeding 165 miles per hour, the hurricane caused unprecedented destruction across the region, flattening entire neighborhoods and causing billions of dollars in damage. Among the many facilities damaged during this storm was a reptile breeding operation located near Miami. When the winds finally subsided and residents began assessing the damage, an unknown number of Burmese pythons, a species native to Southeast Asia, had escaped into the surrounding wetlands. However, the hurricane alone cannot account for the scale of what was to come. Throughout the 1980 seconds and into the 1990 seconds, Burmese pythons had become increasingly popular in the exotic pet trade. These snakes were sold as hatchlings for as little as $10, and their striking patterns and relatively docile temperament made them appealing to people seeking unusual pets. What many buyers failed to understand was the true nature of these animals. A Burmese python that fits comfortably in your hand as a hatchling will grow rapidly, reaching 10 feet in length and weighing 50 pounds within just a few years. These snakes do not stop growing at maturity. They can exceed 20 feet in length and weigh over 200 pounds, making them powerful enough to kill and consume prey as large as a full-grown deer. As these pet pythons grew beyond manageable size, overwhelmed owners faced a serious problem. Unable or unwilling to properly care for these massive predators, many made the fateful decision to release their snakes into the wild. The edge of the Everglades seemed like a logical place to set them free. These releases, combined with the unknown number of snakes that escaped during Hurricane Andrew, created the foundation for an ecological disaster that would take years to fully recognize. Some researchers have questioned whether the standard narrative tells the complete story. The speed and scale of the python population explosion has led some scientists to wonder if there might have been a larger, undocumented breeding facility that released hundreds or even thousands of snakes all at once. While this remains speculation, the rapid establishment of a breeding population does seem to suggest more than just scattered individual releases over time. For several years after these initial introductions, the presence of Burmese pythons in the Everglades was treated as little more than a curiosity. Occasional sightings were reported, but the full scope of what was happening remained hidden beneath the surface. The pythons were not merely surviving in their new environment, They were thriving beyond anyone's imagination. The Everglades turned out to be nearly perfect habitat for Burmese pythons. The warm, humid climate closely mimicked their native Southeast Asian environment. The shallow water and dense vegetation provided ideal cover for these ambush predators. Most critically, the Everglades contained an abundant population of native animals that had no evolutionary history with large constrictor snakes, and therefore possessed no instinctive defenses against them. The Burmese python is an extraordinarily effective predator. These snakes are masters of camouflage, able to remain virtually invisible while lying in wait among vegetation. They can hold their breath underwater for more than 30 minutes, allowing them to hunt in aquatic environments with ease. Perhaps most remarkably, they possess specialized heat-sensing organs called pit organs located along their jawline. These organs allow pythons to detect the infrared radiation emitted by warm-blooded animals, essentially giving them the ability to see body heat even in complete darkness. A raccoon or rabbit foraging at night has virtually no chance of detecting a python before it strikes. The reproductive capacity of these snakes compounded the problem exponentially. A single female Burmese python can lay a clutch containing up to 100 eggs. Without any natural predators to control their numbers, and with an unlimited food supply available, the python population grew at an alarming rate. Current estimates suggest there are between 100,000 and 300,000 Burmese pythons now living in South Florida, though the actual number is impossible to determine with precision given the difficulty of surveying such elusive animals in such challenging terrain. The impact on native wildlife populations has been nothing short of catastrophic. A landmark scientific study published in 2012 documented the extent of the damage in the areas most heavily affected by the python invasion. The findings were almost beyond belief. In these areas, raccoon populations had declined by 99.3%. Opossum populations had fallen by 98.9%. Bobcat numbers were down 87.5%. These figures represent near total elimination of these species from vast areas of the Everglades. To understand the true significance of these numbers, it helps to hear from the people who work in the Everglades regularly. Biologists, park rangers, and hunters who have spent decades in these wetlands describe an eerie transformation. Where they once had to regularly stop their vehicles to allow raccoons or turtles to cross the road, they now drive for miles, sometimes for days, without seeing any mammals at all. The soundscape of the Everglades has changed as well. The rustling and calling of small mammals that once provided a constant background noise has been replaced by an unnatural silence. These small and medium-sized mammals form the foundation of the Everglades food web. Their near elimination has ripple effects throughout the entire ecosystem. Predators that relied on these animals for food have themselves declined. Scavengers that feed on carrion have less to eat. The entire structure that supported thousands of years of ecological balance has been undermined. The Burmese python had found an environment where it faced no meaningful resistance. With abundant prey, ideal habitat, and no natural enemies, these snakes consumed their way through the Everglades with devastating efficiency. By the time officials fully recognized the scope of the crisis, the damage was already severe, and the python population was firmly established. What had once been one of the most biodiverse wetland systems in North America was falling silent, its native wildlife populations collapsing under the pressure of an alien predator they had no ability to resist. As the ecological collapse of the Everglades became increasingly apparent, Florida officials found themselves under mounting pressure to take action. The response they initially launched, however, struck many observers as more a publicity stunt than a serious solution. In 2013, the state introduced the Florida Python Challenge, an annual event that invited members of the general public to participate in hunting the invasive snakes. The program offered cash prizes, including a grand prize of $10,000 for the participant who removed the most pythons. It was part competition, part awareness campaign, and part desperate attempt to find any solution that might work. The Python Challenge quickly became an annual spectacle that attracted hundreds of participants from across the United States and even from Canada. By 2024, more than 800 people registered for the event, arriving with snake hooks, traps, and varying levels of experience in handling dangerous reptiles. These amateur hunters spread out across the accessible areas of the Everglades, wading through swamps and scanning the landscape for any sign of the giant constrictors. That year, participants managed to capture and remove 195 Burmese pythons from the wild. The following year, in 2025, the challenge set a new record with 294 pythons removed. On the surface, these numbers sound impressive. The images of hunters posing with massive snakes made for dramatic photographs that circulated widely in the media. The events generated significant public awareness about the invasion and engaged citizens in conservation efforts. However, when examined in context, the actual impact of these efforts becomes far less encouraging. Consider the mathematics involved. Taking the most conservative estimate of 100,000 pythons currently living in South Florida, the removal of 294 snakes represents less than 0.3% of the total population. If the actual python population is closer to the upper estimates of 300,000 individuals, the impact becomes statistically negligible. The situation becomes even more sobering when considering reproduction rates. Each breeding season, thousands of new pythons hatch from eggs laid throughout the Everglades. The removal of a few hundred snakes annually cannot keep pace with this reproductive output. It is, as some scientists have noted, like trying to empty the ocean with a teaspoon while the tide continues to rise. Recognizing that volunteer efforts alone would not be sufficient, Florida invested in more systematic approaches. The South Florida Water Management District began hiring professional python hunters, contracting with approximately 24 experienced individuals who would be paid an hourly wage to hunt pythons full-time. These contractors were not weekend hobbyists. They were skilled outdoorsmen and women who dedicated themselves to tracking and removing pythons year-round, working in all weather conditions across some of the most challenging terrain in the United States. Since 2017, these professional hunters, along with various state, federal, and private initiatives, have collectively removed over 23,000 pythons from the wild. This represents an enormous investment of time, money, and effort. It demonstrates genuine commitment to addressing the problem. Yet, even this impressive number, accumulated over years of dedicated work, likely represents less than 5% of the total python population. For every single snake that hunters successfully locate and remove, approximately 20 more remain hidden in the vast expanse of sawgrass, mangroves, and wetlands that make up the Everglades ecosystem. The fundamental challenge facing python hunters is that these snakes are extraordinarily difficult to find. They are naturally cryptic animals that blend seamlessly into their surroundings. They spend much of their time motionless, hidden in vegetation or submerged in water. The Everglades itself, with its dense plant growth and limited accessibility, provides nearly perfect cover. A python can be lying just a few feet from a walking observer and remain completely undetected. Frustrated by the limitations of ground-based hunting, officials turned to technology for potential solutions. One approach involved deploying drones equipped with high-resolution thermal imaging cameras. The theory was straightforward. Since pythons are living animals that generate and retain heat, thermal cameras should be able to detect them from above, even when they are hidden beneath vegetation. In practice, however, this approach encountered significant problems. The primary issue is that Burmese pythons are ectothermic, meaning they regulate their body temperature through their environment rather than generating heat metabolically. These snakes are remarkably efficient at thermoregulation, and a resting python often has a body temperature very close to that of its surroundings. In the warm environment of the Everglades, where the ground, water, and vegetation all retain heat, a python's thermal signature becomes extremely difficult to distinguish from the background. Additionally, the thick canopy of trees and mangroves that covers much of the Everglades blocks the view from above, rendering aerial surveillance largely ineffective. Another technological approach involved creating robotic decoys designed to attract pythons. Engineers developed mechanical rabbits that emitted heat and made sounds intended to mimic prey animals. The hope was that pythons would be drawn to these decoys, allowing hunters to set up ambushes. This approach also failed to produce meaningful results. Burmese pythons are ambush predators that rely on stealth and patience rather than active hunting. They typically remain motionless for extended periods, waiting for prey to come within striking distance. The artificial movement and sounds of the robotic decoys apparently did not trigger the hunting response that researchers had anticipated. The most scientifically sophisticated approach has involved the use of what researchers call Judas snakes or scout snakes. This technique involves capturing large male pythons, surgically implanting small radio transmitters, and then releasing them back into the wild during breeding season. The implanted males, driven by reproductive instinct, theoretically lead researchers directly to breeding females. Since female pythons are typically larger and produce the eggs that sustain the population, removing breeding females has a more significant impact than removing males. This program has achieved some notable successes. Researchers have used scout snakes to locate and remove some of the largest breeding females in the Everglades, including individuals that would have produced hundreds of offspring over their lifetimes. However, the method is extremely labor-intensive and expensive. Each scout snake must be continuously tracked, often for months. The signals can be difficult to follow through dense vegetation and across vast distances. Some researchers have reported puzzling behavior from their tracked snakes, with males sometimes leading them on seemingly circular routes or into areas where no other pythons are found, almost as though the snakes are aware they are being followed. This observation, while largely anecdotal, has given rise to an intriguing question among those who work most closely with these animals. The professional hunters and biologists who spend their days tracking pythons frequently comment on what they describe as the uncanny wariness of these snakes. Pythons seem to avoid areas where humans regularly patrol. They appear to learn the locations of traps and alter their behavior accordingly. While this could simply be the result of natural selection, where warier individuals survive while bolder ones are captured, some researchers wonder if there might be something more complex occurring. Could an apex predator species, when introduced into an environment where it faces no natural threats, develop enhanced behavioral flexibility that approaches what we might call intelligence? The idea remains speculative and controversial, but it speaks to the frustration felt by those who have dedicated years to controlling these snakes, only to find them consistently one step ahead. After years of effort, billions of dollars in expenditure, and countless hours of labor by dedicated professionals and volunteers, the sobering reality became impossible to ignore. Scientists and wildlife managers began stating publicly what many had privately concluded. Complete eradication of Burmese pythons from the Everglades is almost certainly impossible. The snakes are too well established, too difficult to locate, and too prolific in their reproduction. The best that can realistically be hoped for is population control that might slow their spread and reduce their impact on native wildlife. This admission represented a profound shift in the conversation around the python invasion. For years, the implicit goal had been to remove these snakes and restore the Everglades to its pre-invasion state. That goal now appeared to be beyond reach. The pythons had won their war of conquest. They had claimed the Everglades as their territory, and no amount of human technology or effort seemed capable of dislodging them. Yet even as officials grappled with this reality, an even more insidious threat was quietly spreading through the ecosystem. The real enemy was not the 20-foot snake that hunters could see and attempt to capture. It was something microscopic, something that had arrived as an unseen passenger with the original invaders, and it was now rewriting the rules of survival in the Everglades in ways that no one had anticipated. While wildlife managers struggled to control the visible threat posed by massive pythons, a far more sinister danger was spreading silently through the Everglades. This threat arrived with the invasive snakes, hidden within their bodies, and it would prove to be even more devastating in some ways than the pythons themselves. The discovery of this biological nightmare began when researchers conducted routine examinations of dead native snakes found throughout South Florida. Scientists performing these examinations noticed a disturbing pattern. Native snake species, including garter snakes, pygmy rattlesnakes, and water snakes, were being found in severely weakened conditions. Many appeared emaciated and showed signs of respiratory distress, struggling to breathe even when they appeared otherwise uninjured. When researchers opened up these snakes to determine the cause of death, they discovered something horrifying. The lungs and airways of these native snakes were packed with dozens, sometimes hundreds, of small parasitic worms writhing inside the tissue. The parasite was quickly identified as Rhabdius pseudosphaerocephala, commonly known as the snake lungworm. This parasitic nematode is native to Southeast Asia, the same region where Burmese pythons originate. Over thousands of years of coevolution, the pythons and the lungworm reached a biological equilibrium. Pythons in their native range can carry the parasite, but it rarely causes them serious harm. Their immune systems and physiology have adapted to tolerate the infection. Florida's native snakes, however, have no such adaptations. They have never encountered this parasite before, and their bodies have no natural defenses against it. The life cycle of the snake lungworm is disturbingly efficient in its simplicity. When an infected snake defecates, the feces contain lungworm eggs. Various insects, particularly cockroaches and beetles, feed on these droppings and ingest the eggs. Inside the insect's body, the eggs hatch into larvae. Small vertebrates such as frogs and lizards then consume the infected insects. When a snake eats one of these infected intermediate hosts, the lungworm larvae begin their deadly journey. Rather than remaining in the digestive system, the larvae actively burrow through the stomach lining and migrate through the snake's body until they reach the lungs. Once established in the lungs, the parasites feed on blood and tissue while reproducing. They physically block airways, making it increasingly difficult for the snake to breathe. The damage they cause leads to severe pneumonia and internal bleeding. Infected snakes become progressively weaker, losing their ability to hunt effectively. Many slowly starve while simultaneously suffocating. Researchers have documented cases where native snakes were found with open, bleeding lesions throughout their lung tissue. In the most extreme cases, dying snakes were observed with lungworms literally crawling out of their mouths as they gasped for air. This represents a second wave of invasion, following in the wake of the pythons themselves. While the pythons eliminated the mammal populations, the lungworm is now systematically attacking the native reptile populations. The discovery sent shockwaves through the scientific community because it revealed that the ecological damage was far more complex and potentially more permanent than anyone had realized. What truly alarmed researchers was how extensively the parasite had already spread. Detailed surveys revealed that at least 18 different species of native snakes in Florida have been found infected with the lungworm. The geographic range of the parasite now extends through dozens of counties across the state. Some reports indicate that infected snakes have been found as far north as Jacksonville, and there is evidence suggesting the parasite may be creeping toward the Florida Panhandle. The most terrifying aspect of this discovery is that the lungworm has achieved biological independence from its original host. When the parasite first arrived in Florida inside Burmese pythons, it was entirely dependent on that species for its spread. However, the lungworm has now successfully established itself in native snake populations. It is spreading from native snake to native snake through the environmental route involving insects and small vertebrates. This means that even if every single Burmese python was somehow removed from Florida tomorrow, the lungworm would continue to persist and spread. It has become a permanent part of the Florida ecosystem. The ecological implications of widespread native snake decline extend far beyond the snakes themselves. Snakes play crucial roles in controlling rodent populations and serving as prey for larger predators. When snake populations collapse, rodent populations can explode, potentially leading to increased crop damage and disease transmission. Meanwhile, predatory birds such as hawks and eagles that feed on snakes lose an important food source, potentially affecting their populations as well. The cascading effects ripple through the entire food web. These confirmed facts have given rise to more speculative concerns among some researchers. The lungworm has already demonstrated its ability to jump from an Asian host species to multiple North American host species. This represents a significant adaptive leap. Some scientists have quietly raised the question of whether the parasite could jump again, potentially infecting mammals or even humans. Official statements emphasize that this is highly unlikely based on the parasite's known biology. However, these same scientists acknowledge that they did not predict the parasite would successfully infect native North American snakes either. Yet it clearly has done so. The possibility of domestic animals becoming infected represents another concern. Dogs or cats that might consume infected frogs or snakes could theoretically be exposed to the parasite. Hunters and researchers who regularly handle wild snakes could face exposure risks that are not yet fully understood. While current scientific consensus holds that the risk to humans and domestic animals is minimal, the parasite's demonstrated ability to adapt to new hosts makes confident predictions difficult. Interestingly, researchers have discovered that one native species, the Florida cottonmouth, appears to show unusual resistance to the lungworm. While cottonmouths can become infected, they seem to tolerate the parasite better than other native snake species. The mechanism behind this resistance remains unknown. Some researchers speculate it could be genetic, related to the cottonmouth's immune system. Others wonder if something in their diet or behavior provides protection. This resistance has sparked interest in whether studying the cottonmouth might reveal insights that could lead to treatments or management strategies for protecting other native species. The situation facing Florida had evolved into something far more complex than a simple invasive species problem. It was now a multi-layered ecological crisis. The visible enemy, the python, had proven nearly impossible to control through conventional means. The invisible enemy, the lungworm, appeared to be completely beyond human ability to manage. There was no vaccine, no treatment, and no method to remove a microscopic parasite from millions of acres of wetland. In the face of these compounding disasters, with public frustration mounting and the ecosystem continuing to deteriorate, Florida officials announced a plan that seemed so absurd to the general public that it immediately became the subject of international mockery. The state declared its intention to release hundreds of additional snakes into the already snake-infested Everglades. The announcement was met with a wave of disbelief and derision. Social media exploded with commentary about Florida's apparent insanity. News outlets around the world ran headlines treating the plan as yet another example of misguided environmental management. Critics immediately drew comparisons to some of history's most notorious ecological blunders. They pointed to Australia's cane toad disaster, where toads introduced to control beetles in sugarcane fields instead ignored the beetles and multiplied into billions, becoming a toxic plague that continues to devastate native wildlife. They referenced the introduction of mongooses to Hawaii, where the animals brought in to control rats in sugar plantations turned out to be active during different hours than the rats, and instead decimated native ground-nesting bird populations. These historical failures seem to prove that introducing new species to control existing invasive species inevitably makes situations worse rather than better. To the average person following the story, Florida's plan sounded like exactly the kind of hubris that had caused ecological disasters in the past. It appeared to be humans attempting to play God with nature, ignoring the obvious lessons of history. The ridicule was immediate and widespread, with many predicting that this would become another case study in environmental mismanagement taught in biology classrooms for generations to come. However, beneath the sensational headlines and public mockery, there was a story that few people understood. This was not a hastily conceived plan driven by desperation. The snake being released was not some foreign species imported from another continent. It was the eastern indigo snake, and it was not an invader. It was royalty returning to reclaim a throne that humans had stolen from it decades earlier. The eastern indigo snake holds a special place in North American ecology. It is the longest native snake species on the continent, capable of reaching lengths of up to 9 feet. The snake's appearance is striking, with scales that shimmer in an iridescent blue-black color, complemented by patches of reddish-orange coloring beneath the chin. While its beauty is remarkable, the true significance of the eastern indigo lies in its ecological role and its extraordinary dietary habits. The eastern indigo snake is what biologists call ophiophagous, meaning it specializes in eating other snakes. This dietary preference makes it unique among North American reptiles. Even more remarkably, the eastern indigo possesses complete immunity to the venom of native pit vipers, including rattlesnakes, cottonmouths, and copperheads. When hunting other snakes, the indigo does not employ constriction like pythons do. Instead, it uses its powerful jaws to pin prey down and swallows it alive, seemingly unbothered by any defensive struggles. This predatory prowess earned the species its nickname as the Emperor of the Forest. Historically, the eastern indigo snake's range extended across a vast territory throughout the southeastern United States. The species was found from South Carolina through Georgia and throughout Florida, extending west into Mississippi and Alabama. However, this expansive kingdom gradually crumbled due to 2 interconnected ecological factors: the destruction of longleaf pine forests and the decline of gopher tortoise populations. The longleaf pine ecosystem once covered approximately 90 million acres across the southeastern United States. These forests provided ideal habitat for the eastern indigo snake and countless other species. However, Extensive logging operations, agricultural conversion, and urban development combined with fire suppression policies to eliminate roughly 97% of the original longleaf pine habitat. As the forests disappeared, so too did the species that depended on them. The connection to gopher tortoises proved equally critical. Eastern indigo snakes do not dig their own burrows. Instead, they rely almost entirely on the deep, sandy burrows excavated by gopher tortoises. These burrows function like underground refuge systems, providing shelter from extreme temperatures, fire, and predators. The gopher tortoise is considered a keystone species because over 350 different species utilize these burrows. When the tortoise population declined due to habitat loss and hunting, particularly during the Great Depression when desperate families dug up tortoises for food, the eastern indigo lost its essential shelter. The combination of habitat destruction and loss of burrow access proved devastating. By 1978, the eastern indigo snake population had collapsed so severely that the species was listed as threatened under federal law. The snake had been completely eliminated from Alabama and from much of northern Florida. The emperor had been dethroned not by a superior predator, but by human activity that destroyed the foundation of its existence. What appeared to the public as a reckless plan to release more snakes into an already snake-plagued ecosystem was actually the culmination of decades of careful conservation work. Multiple organizations and state agencies had been collaborating for years on a comprehensive restoration program. This effort involved captive breeding programs to maintain genetically diverse populations of eastern indigo snakes, habitat restoration projects focused on replanting longleaf pine forests, and protection initiatives for remaining gopher tortoise populations. The release of snakes into the wild represented just one component of a much larger ecological restoration effort. The careful scientific foundation underlying this project did not prevent skeptics from raising valid concerns. The Everglades ecosystem had been profoundly altered by the python invasion and the subsequent collapse of mammal populations. Introducing a native apex predator into an already disrupted system carried inherent risks. Questions remained about what the indigo snakes would eat if python populations proved too large or too difficult to hunt. Some worried that the indigos themselves could become a problem species in an ecosystem no longer capable of supporting them in their historical numbers. While the scientific community moved forward with the restoration plan, events in the Everglades were revealing that nature itself was already beginning to mount a defense against the python invasion. In December, researchers tracking a large male python nicknamed Loki made a startling discovery in Big Cypress National Preserve. The 13-foot, 52-pound python, which had been fitted with a GPS tracker for a breeding study, was found dead under unusual circumstances. The massive snake's head had been completely severed and hidden beneath nearby vegetation. The discovery initially baffled researchers. What creature in the Everglades possessed the capability to kill such a large apex predator? Trail cameras positioned in the area soon provided the answer. The footage revealed that a native bobcat, estimated to weigh barely 25 pounds, had successfully hunted, killed, and consumed portions of the python. This represented a remarkable reversal of fortune. For 2 decades, pythons had been the undisputed apex predators, feared by all native wildlife. Now, one of Florida's native predators had turned the tables. Wildlife biologists considered this event unprecedented. While some experts suggested that a recent cold snap might have slowed the python's reflexes and made it vulnerable, others began wondering if something more significant was occurring. The incident with Loki was not entirely isolated. Additional observations across Florida documented alligators ambushing and consuming smaller pythons. The endangered Florida panther had also been documented taking on these invasive snakes. These sightings raised an intriguing possibility. Could native predators be learning to exploit a new prey source? The question of whether animals can learn and pass on hunting techniques remains scientifically complex. However, field biologists who work regularly in the Everglades have noticed patterns that suggest some form of behavioral adaptation might be occurring. Native predators appear to be discovering the vulnerabilities of pythons, perhaps through trial and error, or by observing other successful hunts. While this adaptation offers a glimmer of hope, it must be kept in proper perspective. A single bobcat successfully hunting one python cannot offset the presence of hundreds of thousands of pythons hatching throughout the region annually. The native predators had scored points, but they remained far behind in the overall contest. The real breakthrough in the restoration effort came hundreds of miles north of the main python invasion zone. Conservation teams had been releasing captive-bred eastern indigo snakes into protected areas in northern Florida, specifically the Apalachicola Bluffs and Ravines Preserve. This location, far from the python-dominated Everglades, represents part of the indigo snake's ancestral range. Researchers tagged and tracked the released snakes, monitoring their survival and behavior. In autumn of 2023, trail cameras at the preserve captured footage that exceeded all expectations. The cameras documented 2 wild-born hatchling eastern indigo snakes. These young snakes were the offspring of previously released adults, representing the first successful reproduction of eastern indigo snakes in the wild in northern Florida in nearly 50 years. This was not merely survival, this was a genuine recovery. The confirmation that one of the young snakes lacked a tag provided definitive proof that it had been born entirely outside of human management. The indigos were not simply persisting in their reintroduced habitat, they were thriving, hunting, and successfully raising the next generation. As monitoring continued through 2024 and into 2025, the success became even more apparent. Researchers documented additional sightings, including a robust 6-foot male, and identified 19 other snakes from earlier release cohorts that were still alive and active in the area. The success of this restoration effort hinged on the painstaking work of rebuilding the ecosystem itself. The protection and restoration of longleaf pine habitat, combined with conservation efforts for gopher tortoise populations, had recreated the conditions necessary for eastern indigo snakes to flourish. The ecosystem was beginning to function as it had historically, with all the necessary components in place. It is important to maintain realistic expectations about what this achievement represents. The eastern indigo snakes currently being released and breeding successfully are located in northern Florida. The python stronghold remains hundreds of miles south in the Everglades and surrounding wetlands. The 2 populations are not yet in the same geographic area. The indigos are not currently hunting pythons, nor is there any guarantee they would be successful in doing so, even if they encountered them. However, the significance of this restoration extends beyond any potential direct conflict with pythons. The unexpected aftermath that researchers discovered was twofold. First, the evidence suggests that native ecosystems possess more resilience and adaptive capacity than pessimistic projections indicated. Native predators, including bobcats and alligators, are demonstrating the ability to incorporate pythons into their diet under certain circumstances. Second, and perhaps more importantly, a conservation approach based on patience, rigorous science, and respect for natural ecological processes has produced tangible results. For decades, the dominant narrative surrounding the Everglades focused on human failure. Efforts to contain the python invasion failed. Attempts to remove the snakes through hunting and technology failed. High-tech solutions involving drones and robotic decoys failed. The search for a quick fix, a single intervention that would solve the crisis, consistently ended in disappointment. The restoration of the eastern indigo snake represents a fundamentally different approach. Rather than seeking to dominate nature through technology, this effort focused on restoring natural balance and allowing native species to reclaim their ecological roles. The python invasion remains an ongoing crisis. The lungworm parasite continues to spread unchecked. However, the footage and data emerging from Florida's conservation efforts reveal something that few predicted: genuine hope grounded in ecological resilience. Yet this hopeful development leads to profound questions about the future. The eastern indigo snake population is gradually expanding southward as restoration efforts continue. The python population, meanwhile, continues to spread northward beyond the Everglades. At some point, these 2 populations will meet. What happens during that collision remains unknown. Even more concerning is the question of what occurs when the spreading lungworm encounters the restored indigo snake populations. The parasite is also moving northward, infecting native snake species as it goes. If the lungworm reaches the areas where eastern indigos are being re-established, will these native snakes prove resistant? Or will decades of restoration work result in feeding a recovering species directly into an invisible plague? The real aftermath of the Everglades crisis is not a concluded story with a clear ending. Instead, it represents the opening chapter of a new and uncertain conflict involving three major forces: the invasive python, the parasitic lungworm, and the returning emperor. Whether this three-way interaction will lead to ecological recovery or simply represent the next phase of environmental collapse remains to be seen.